A simple pendulum made of mass 10 gram and a metallic wire of length 10 centimeter is suspended vertically in a uniform magnetic field of 2 Tesla. The magnetic field direction is perpendicular to the plane of oscillation of the pendulum. If the pendulum is released from an angle of 60 degrees with the vertical, then maximum induced EMF between the point of suspension and the point of oscillation is the induced EMF in a metallic rod when it is rotated about one of its ends in a magnetic field which is perpendicular to the plane of rotation is given by E equal to B omega L square upon 2, and this induced EMF would be maximum when omega is maximum. Now let us come to this pendulum. Pendulum is released from an angle of 60 degrees with the vertical. So at point P, this has only potential energy, and at point Q, this will have only rotational kinetic energy. So at point Q, its angular velocity would be maximum. Let us apply conservation of energy between points P and Q. At point P, this has only potential energy, and this is equal to mg into h. H is L minus L cos of 60 degree, and rotational kinetic energy at point Q is half I omega square. And this gives us mg into L multiplied by 1 minus cos of 60 degree. Moment of inertia of the mass of 10 gram about point O will be ml square into omega square. So this gives us m cancels m and L cancels 1 of L. So we get G is 10, cos 60 degree is 1 by 2, and this is equal to 1 by 2 into length L is 10 centimeter. So this can be written as 0.1 meter. So this gives us 10 by 2 equal to 1 by 2 into 1 by 10 into omega square. 2 cancels 2. So we get omega square equal to 100, and this gives us omega equal to 10 radian per second, and this is the maximum angular velocity, 10 radian per second. Now let us find out induced EMF, rather the maximum induced EMF in the metallic rod or the wire. Magnetic field is 2 Tesla. Omega we just got 10 radian per second. Length L is 0.1 meter upon 2. This is equal to 0.1 volt. This can be written as 0.1 into 10 raised to the power 3 millivolt. So this is equal to 100 millivolt. Therefore answer is 100 millivolt, and this is the maximum induced EMF.